Today let us see how to find the rank of a matrix. This is class 1. This topic is useful for degree students and engineering students. How to find the rank of a matrix. Before finding the rank of a matrix, let us have some idea about matrix. What is a matrix? A matrix is a rectangular array of elements. The elements can be numbers, symbols, expressions, etc. For example, consider the matrix 1, 2, 3, 5. Okay, this is a matrix. Let us name this matrix as A. How many rows and how many columns it has? 2 rows and 2 columns. Therefore, we can say the order of this matrix is 2 by 2. Equal number of rows and equal number of columns. Therefore, it is called a square matrix of order 2. Now, what is a determinant? Now, the value computed from the elements of a square matrix is called its determinant. Let us see the determinant of the matrix A. Determinant of A is equal to determinant of this matrix is determinant of 1, 2, 3, 5. What's the value of this determinant? 1 into 5, that is 5, minus 3 into 2, that is 6, that is equal to negative 1. This is the value of the 2 by 2, determinant of the 2 by 2 square matrix A. Okay. Now, what's the definition of the, how will you find the rank of a matrix? The rank of a matrix is the order of the largest square submatrix whose determinant is not equal to 0. Before finding the rank of a matrix, we should have some idea about the elementary transformations of a matrix. That is, what are the elementary transformations of a matrix? Number 1, interchange of any 2 rows or columns. Okay, for example, consider the matrix A is equal to matrix 2, 1, 3, 5. What's the first row? 2, 1. Second row, 3, 5. I can interchange the rows, and this matrix A is equivalent to the matrix 3, 5, 2, 1. I can interchange the first row and second row. Similarly, I can interchange the columns also. That is, this is equivalent to, what's the first column? 2, 3. Second column, 1, 5. Now I am writing like this, 1, 5, 2, 3. Interchanging the 2 columns. So we can interchange either the rows or the columns of a matrix. That is the property number 1 under the elementary transformations of a matrix. Property number 2, multiplication of the elements of any row or column by any non-zero number. We can multiply the row or column by a non-zero number. For example, consider the matrix A is equal to, give me any matrix A, tell me. Okay, 2, 4, 3, 9. I can multiply the first row by a scalar, any non-zero number, and suppose I am multiplying the first row by 2, then 2, 4, 2 has to be multiplied by 2, 4 has to be multiplied by 2. Therefore, first row will change to 4, 8. Second row, 3, 9. Okay, similarly I can multiply the column also. The multiplication of the elements of any row or column by any non-zero number. That is the condition number 2 or property number 2. What's the third one? Addition to the elements of any row or column, the corresponding elements of any other row or column multiplied by any number. Okay, now consider, let us take the matrix A is equal to 2, 1, 3, 3, 5. Okay, now I can multiply the first row. First row is R1. This is the second row is R2. I can multiply the first row by a scalar, any scalar, that is R1. R1 multiplied by 2R1. And this 2R1 can be added to the second row. That will give 2R1 plus R2. Therefore, what will be the transformation performed on the second row? That is A is equal to, matrix A is equal to R2 is equal to R2 plus 2R1. That is 2, 1 is the first row. First row I am multiplying by 2. 2 into 2, that is 4. 4 plus 3, 7. Here also multiplying the second element here by 2. 2 into 1, 2. 2 plus 5, 7. Okay. This is the elemental transformation performed here. Therefore, you can perform it either for the rows or for the columns. Now let us see the next definition. The row equivalent canonical matrix. What is a row equivalent canonical matrix? That is, any non-zero matrix A is said to be of rank R if it can be reduced to row equivalent canonical matrix C as follows. What is the number 1? The first R rows contain at least one non-zero element each. Number 2, the first non-zero element in each row is 1 and the column containing that 1 has only zeros elsewhere. Number 3, the remaining rows contain only zeros. If these three conditions are satisfied, the matrix is called the row equivalent canonical matrix. Given any matrix A, we can reduce that matrix to the row equivalent canonical matrix in this way, and then the rank of the given matrix is said to be R. Okay. Also, this is also known as an echelon form. Row equivalent canonical matrix, or also known as echelon form. Now, in other words, we can say that the rank of a matrix in echelon form is the number of non-zero rows in that matrix. Now, let us see an example. See the question. Find the rank of the matrix 1, 2, 3, 2, 4, 7, 3, 6, 10. What's the order of this matrix? 3 rows and 3 columns. 3 by 3 matrix. Okay. Now the given matrix, I am writing this here again. Matrix 1, 2, 3, 2, 4, 7, 3, 6, 10. That is equivalent to, I am writing the first row as it is. 1, 2, 3. Now what is the transformation performed on the second row? The second row is R2. R2 is transformed as R2 minus 2R1. 2R1, what is 2R1? 2 into 1, that is 2. Here the first element here is 2. 2 minus 2, 0. Again multiplying 2 by 2, that is 4. 4 minus 4, that is equal to 0. Then again multiplying 3 by 2, that is 6. 7 minus 6, 1. Now the second row is transformed in this way. From 2, 4, 7, by performing this transformation, it becomes 0, 0, 1. Okay. Now see the third row here. What's the third row? 3, 6, 10. What's the operation I am performing here? R3 is transformed as R3 minus 3R1. That is, I am multiplying the first row by 3. And then R3 minus 3R1 is taken. Therefore, R3, 3 is here. 1 into 3 is 3. 3 minus 3, 0. Okay. Now here in R3, the second element is 6. I have to multiply the first row by 3. 3 into 2, 6. 6 minus 6 is equal to 0. Now here what about 3? 3 into 3, 9. 10 minus 9 is equal to 1. Therefore, the third row, that is in the previous case, it was 3, 6, 10. After performing this operation, 3, 6, 10 is changed to 0, 0, 1. So these two matrices are equivalent matrices. Okay. I am writing this matrix once more. Matrix 1, 2, 3, 0, 0, 1, 0, 0, 1. Now what is the operation? I am performing an operation on the first row. What is R1 here? R1 is R1 minus 3R2. This is the operation I am performing on the first row R1. R1 is equal to R1 minus 3R2. That is 1 minus 3 into 0. 1 minus 3 into 0 again 1. 2 minus 3 into 0 again 2. 3 minus 3 into 1, this element will become 0. Therefore, the first row 1, 2, 3 is transformed as 1, 2, 0. Now the second row here I am writing as it is 0, 0, 1. See the third row. I am transforming the third row. What is the transformation I am using here? R3 is transformed to R3 minus R2. R3 minus R2. That is 0 minus 0, 0. 0 minus 0 again 0. 1 minus 1, 0. Therefore, here 0, 0, 1 is transformed as 0, 0, 1. Now see the matrix obtained. After performing the transformations with respect to the rows, we get the matrix as 1, 2, 0, 0, 0, 1, 0, 0, 0. See whether this satisfies all the conditions of the row equivalent canonical matrix. See the first row, which is the first row, which is the first R rows contain at least one non-zero element. First row has the first non-zero element is 1. The first non-zero element in each row is 1. And the column containing that one has only zeros. The first row, the first non-zero element is 1. And see the column containing 1. What about the column containing 1? Here 1, 0, 0. All the other elements are zeros. The column containing 1 has other elements as 0. Now see the next row. Which is the first non-zero element? 1. What about the column containing 1? All the other elements are 0. Here 0, here 0. That is also, this condition is satisfied. And what about the remaining rows are 0. Third row is equal to 0. Okay. Therefore, all the conditions of the row equivalent canonical matrix are satisfied. So what is the rank of this matrix? Can anybody say? The rank of this matrix is, rank is equal to, rank is 2. Rank of this matrix is 2. Okay. So you should have an idea of elemental transformations, and after performing the elemental transformation you get the row equivalent canonical matrix, and after obtaining the row equivalent canonical matrix we can find the rank of the given matrix. Therefore the rank of the what's our given matrix? The given matrix 1, 2, 3, 2, 4, 7, 3, 6, 10. The rank of that matrix is 2. It is given matrix is equivalent to, we have transformed the given matrix 1, 2, 3, 2, 4, 7, 3, 6, 10 is now equivalent to the canonical, row equivalent canonical matrix, because we are performing the operations only on rows. Remember that. Columns, we are not performing any transformations on the columns. Okay. This is equivalent to 1, 2, 0, 0, 0, 1, 0, 0, 0. That is, the rank of this matrix is equal to, given matrix is equal to 2. Okay. So we conclude today's class. Thank you.